Hello everyone, today we are going to discuss about Beer-Lambert's law, its derivation and deviation. So the Beer-Lambert's law is state as when a monochromatic light of initial intensity IO which is passes through a solution in transparent vessel, some of the light is absorbed that the intensity of the transmitted light I is less than I naught. So there is some loss of light intensity from scattering by particle in the solution and reflection at the interfaces, but mainly from the absorption by the solution. The relationship between I and I naught, which is depend on the path length of the absorbing medium. So the I and concentration of absorbing solution C. So these factors are related in the law of Lamberts and Beers. So the monochromatic light which is absorbing solution concentration C incident beam and intensity I naught which is emergent beam intensity I which is depend on the depth of the solution which is denoted as L. So the Beer-Lambert's law are Beer law and Lambert law is a separate terminologies. So Beer law stated as when a monochromatic light passes through an absorbing medium, its intensity decreases exponentially as the concentration of absorbing medium increases. So it is denoted as A is directly proportional to the C and whether A is a absorption and C is a concentration of the medium. So the Lambert's law is stated that when a ray of monochromatic light passes through an absorbing medium, its intensity decreases exponentially as the length of absorbing medium increases. So it is denoted as A is directly proportional to the L. A is denoted as absorption and L is denoted as path length of the solution. So the Beer-Lambert's law equation is overall denoted as A is equal to EBC, whether the A is denoted by the absorbance and molar absorptivity is denoted as E and path length is denoted as B. So the concentration is denoted as C.
Laws governing absorption of radiation. So, the experimental measurement are usually made in terms of transmittance, which is defined as T is equal to IT by IO, where in short IT is final intensity while IO is initial intensity. The relation between A and T is A is equal to log 1 by T, which can also be written as minus log IT by IO. The absorption of light by a sample can be described by given diagram. There are two laws which govern absorption of radiation. They are Beer's law and Lambert's law. So what exactly Beer's law is? So this law states that when a beam of monochromatic radiation is passed through a solution of an absorbent substance, the rate of decrease of intensity of radiation with concentration of the absorbing solution is proportional to the intensity of incident radiation as well as the concentration of the solution. That is, in short, minus di by dc is directly proportional to the I, where if we interchange, then it will become minus di by dc is equal to k dot I, or which can also be written as minus di by I is equal to k dot dc. So give this equation 1. Let the concentration be 0, then I is equal to I O. And when the concentration is C, then I is equal to IT. So by integrating the equation 1, we get that is limit IO to IT minus DI by I is equal to limit O by C k dot dc. So when C is equal to 0, intercept B is equal to 0. Thus, we can get this equation as minus L minus log IT minus log I0 is equal to K by C minus 0 plus 0. So after further equation, we get the equation IT by IT is equal to IO E minus e to the power minus KE, or which can also be written as IO is equal to IT E by E raised to power KE. So this is the final equation of the Beer's law. Now coming back to the Lambert's law, what exactly Lambert's law is? So basically Beer's law and Lambert's law are, if we combine, then we get the final Beer and Lambert's law. So Lambert's law states that when a beam of monochromatic radiation passes through a homogeneous absorbing medium, the rate of decrease of intensity of radiation with thickness, that is path length, of the absorbing solution is proportional to the intensity of incident radiation. That is, it can be also written as minus di by dt is directly proportional to the I, that is the intensity, or minus di by dt is equal to k dot I. K is the proportional constant. So, which can also be written as minus di by I is equal to k dot dt. Name this equation as equation 4. So, when the path length is 0, then I is equal to IO, and when the path length is t, I is equal to IT. By integrating the equation, and we get the equation that is limit IO to IT minus DI by I is equal to limit O by C K dot dt. Get this equation and name it as equation 5. So when t is equal to 0, intercept b is equal to 0, thus minus in the bracket log I by t minus log I by 0 is equal to k t minus 0 plus 0. So by further modification, we get the equation it is equal to I0 e raised to the power minus kt, or which can also be written as IO is equal to IT e to the power kt. So name this equation as equation 6. So by combining the equation 3 and equation 6, we get that is IO is equal to IT e raised to the power kct. Name this equation as equation 7. The above equation can also be written by changing the logarithm to the base 10. So when we change the natural logarithm to the base 10, we get the equation that is IO is equal to I10 10 raised to power act, where a is equal to extension coefficient is equal to k by 2.303, that is the constant value. So the equation, which can also be written as log io by it is equal to act. So we already know that what exactly transmittance is. So I've already explained you in a previous slide that transmittance is expressed in terms of percentage t, that is t is equal to it by I0, and absorbance, that is a is equal to log 1 by t. So which can also be written as minus log t. So substituting the transmittance formula in t, then we get the equation that is log IO by IT is equal to ACT is equal to ECT. So E is equal to molecular extension coefficient or molar absorptivity. So E is equal to molar absorptivity. C is equal to concentration of solution in moles. T is equal to path length of the sample. So this is the final formula of Beer-Lamberts law.
Deviations. There are three types of deviations: A. Real deviation or true deviation. B. Spectral deviation. C. Chemical deviation. Real deviation or true deviation. The Beer law is successfully describing absorption behavior of dilute solution only so Beer's law is valid at low concentration. In some time, we can observe real deviation. If concentration doubles, the absorbance is not relatively double because of real deviation mainly observed in high concentration analyte. At low concentration, refractive index is not significant. Concentrations of sample from 106 to 103 m, n is equals to 1. At high concentrations, refractive index is significant. Concentrations of sample above 103 m, 1 is more than n. So here observed non-linearity curve. B. Spectral deviation. The graph contains the narrow bandwidth as a monochromatic radiation. The graph contains the larger bandwidth with as polychromatic radiation. This leads to deviation from the Beer's law. Spectral deviation is also due to the stray radiation. Sometimes we can also observe spectral deviation due to stray radiation. Stray radiation means unwanted radiation which reaches to the detector that resulting from the reflection, refraction, scattering of light by solid particles and other types of molecules. Spectral deviations mainly due to polychromatic radiation, stray radiation. C. Chemical deviation. Chemical deviation arises if the absorbing species undergo chemical changes such as 1. Association molecules, 2. Complex formation, 3. Dissociation molecules, 4. Hydrogen bonding, 5. Hydrolysis, 6. Ionization or polymerization, 7. pH changes in sample. When the concentration of the sample increases, the molecule can associate to form the dimers and polymers which will again have different absorption. In order to prevent the chemical deviation, we have to check whether the sample is undergoing association or dissociation, and we have to fix the pH by using suitable buffer systems.